Howdy, howdy, everybody. Welcome, welcome. Didn't we do this topic yesterday? Yeah, we do it every Tuesday and Wednesday. At least we try to, but the last month and a half have been a little bit hectic. Hence why they haven't been as regular. But yeah, we do them back to back, Tuesday, Wednesday. And the reason for that is because I generally have meetings on Tuesdays and Wednesdays, and because some of my collaborators are in other countries, which have distant time zones. Sometimes it's best to meet in the morning. Welcome, welcome. Howdy, howdy. Hope everybody's having a good day. A great day, even. We will get started as soon as people trickle in and we start having some questions asked. I should probably hydrate in the meantime. How do we realistically collect lots of hydrogen to fuel large interstellar vehicles? Well, look. It turns out that hydrogen's like the most abundant, probably the most abundant element in the solar system. Even on Earth, it's very, very abundant. I mean, the surface of the Earth is 70% water, and you can just take water and then you can pass electricity through it and you end up with hydrogen gas. So that's one way to do it. But like, if we can get to, you know, if we can become an interplanetary species, then we can just like go hang out by Jupiter and just collect as much hydrogen as we want, because that planet is like, not what, like 90 or it's like 70% hydrogen or something, some huge chunk. Oh, I have to refresh this so that the TikTok questions get through. Is it possible to revert a black hole back into a star and to restore the information inside it? No, at least not with classical physics. I mean, like, maybe there's some weird quantum stuff that you can do, but not, kind of by definition, if it has an event horizon, then there's nothing that you can do to undo it, because an event horizon is a global space-time surface. It's globally defined. So if it doesn't have an event horizon, or if it doesn't, yeah, how do I want to say this? If at some point in the future it's not a black hole anymore, then it never had an event horizon to begin with. Is time travel possible? To the future, sure. To the past, I suspect not. Likelihood of aliens not like super intelligent, but in general, I think it's close to 100%. In fact, there may even have been life on Mars. We have, you know, there's pretty compelling evidence that was announced last year that they found evidence of life on Mars. What are your thoughts on what material is at the edge of the event horizon? So the event horizon is not an object with a surface. So the event horizon is just a place. Can you explain the formation and composition of a neutron star? Yeah, so a neutron star forms in a neutron star forms after a supernova. So you have a big star, it explodes. The core becomes the core goes from iron to basically neutronium. And so during that whole collapse process, you end up with basically just a big soup of neutrons and a few other things. The neutron star itself has a little bit more of a complex structure than just pure neutronium. At the surface, you have actual atoms, and you have heavier and heavier atoms as you go deeper and deeper, with more and more neutrons and fewer electrons and protons. Eventually, below the crust, you end up with something that looks like pure neutronium. Below that, it's not as clear, but it seems like you get something called nuclear pasta, which is the actual name in the literature. There's basically different phases of like nuclear matter. And then we're not really sure what's going on at the core of the neutron star, but it's possible that there's like other kinds of matter, like strange matter or exotic matter things at the core. How is the sun on fire? Well, it's not on fire. The sun is just a big glowing, like you can think of it like a big glowing neon sign, right? It's plasma, and plasma can glow. Well, okay, that's actually probably a little bit misleading. It is plasma, and it is glowing, but it's glowing because it's hot, not because it's sparse and because of the atomic transitions. The reason it's glowing, the reason why it's hot, is because it does nuclear fusion in the core. So you've heard of like these nuclear bombs that like fuse hydrogen together, and these are like hugely energetic things. Well, that's what's happening at the core of the sun, and that's what's providing the heat for the rest of the sun to get hot and then glow. Let me rephrase. What material would matter become after the event horizon? Wouldn't pressure affect matter inside? It's hard to say. From the matter's perspective, I mean, it'll experience tidal forces, so it'll be stretched. So in principle, like right before, but this is not something that happens after the event horizon. This is something that happens as you get closer to the singularity, if there is such a thing. So it's completely speculative. Really hard to say what's going on definitively. Do you have a book you'd recommend for people who want to dip their toes into physics? Yeah. Probably anything by Neil deGrasse Tyson is going to be friendly. A Brief History of Time by Stephen Hawking is also quite good, if you're just getting started. What is stopping us from doing nuclear fusion? Well, we can do nuclear fusion. We just don't know how to contain it, right? Like, we have nuclear bombs. We have like hydrogen bombs. Hydrogen bombs use nuclear fusion as their power source. Sort of. It's complicated, but that's at least involved in the process. The trouble is containing it and not just having an explosive reaction, but like having a sustained reaction. That's the hard thing. And it's because it's really, really hot, really, really high pressure. It's hard to contain that. You need really, really strong magnets, and you have to like have really, really fast reaction times for your like magnetic field strength changing to like adjust, and it's just a complicated problem. I want to get into astrophysics currently in high school. Any tips? Stay in school, get good grades, read stuff that keeps your interest. Like books. Read books like pop science books, or even slightly more advanced like pseudo pop science books. Like there's a series of books that Sean Carroll is putting out called The Biggest Ideas in the Universe. It's a really good series. I think the first two are out. It's sort of pop science, but it's also sort of like an actual physics book. Are you a physicist? Yeah. I mean, if you're somebody who does physics, then I would imagine so. That's kind of like what you do. Why do you dislike Professor Jiang? Because he's a bad person who spreads conspiracy theories and spreads disinformation and hate. Like, what's the difference between mathematical physics versus physics? Mathematical physics is, it's more focused on proving things about the physics than it is about like just kind of speculating. Not I shouldn't say just speculating, but think of theoretical physics, but even more mathy. If I want to reach the end of the universe, if I wait long enough, will I get there? Well, as far as we can tell, there isn't an end of the universe. How do you feel about all the wacky fundamental theories of everything? Well, there aren't a whole lot, at least none that are really taken seriously. Are you currently in a postdoc or searching for one? No, and only loosely. It turns out I have enough flexibility doing the social media science communication stuff, and I make enough money to support myself this way, that this gives me more flexibility for my research. The only reason I would look for a postdoc is if it's a really good opportunity to work with somebody that I really want to work with, or for clout, basically. I still get to do the research. I still get to write the papers that I want to write. I still get to think about the problems that I want to think about. I have, I have plenty of time to work on those problems. So, what exactly is the Avogadro's constant? It's just a number. It's just a number, and it happens to be that number is how you can translate between it. Like, that's roughly the number of atoms that you need in order to have like a macroscopic amount of something. You should debate Lord Jamar like Professor Dave did about the flat earth. I don't know who Lord Jamar is, but I'd be happy to debate anybody. A lot of these questions are like very philosophical in nature and not really relevant. Why is weight shown as pounds on someone's driver's license and not shown as mass? Because weight is a force, right? Weight is the gravitational pull that the Earth has on you. It's that's what weight is. Mass is not a force. Mass is a mass. Do you think CERN would discover anything huge in the upcoming years? It's hard to say. I don't really pay attention. Like, I'm not following all of the things that CERN is working on just because it's not my area of physics. My area of physics is more of the gravitational and cosmological stuff. But I mean, it's possible. Unfortunately, though, it's seeming like more and more often we're just getting more confirmation of the standard model, which is kind of disturbing. Did you watch Ian's stream yesterday with Angel calling you out? I did. It was so funny. Hardest part of doing a PhD? Doing the reading, at least for me, because it's very hard to just sit down and ignore a problem that you're trying to make progress on and just read something because you know it'll be good for you. What's the definition of a measurement in quantum mechanics? This is that's a question that we don't have a good answer for. Plausibly, the right answer is something like when a large classical system interacts when a large system that can be described approximately classically interacts with a small quantum system, but it's really hard to say. Angel was so desperate for you to come up. I know, it was so funny. What are the best paying jobs you can get being a physicist? I mean, like, probably director of a national lab would be my guess. We have a super chat from Saint Diluted. Thank you for the $5, Diluted. Have you seen Colin Furz's magnet suspension mountain bike and skateboard? What do you think about this application? I haven't seen it. I've seen clips, but I haven't like watched the video. I like Colin Furz generally. I'm not sure, like, I don't know how useful that is. I don't know why you would want that. I think that like regular shocks would be fine, right? String theory, quantum mechanics. String theory is kind of like a part of quantum mechanics. Quantum mechanics is a large, how do I want to say this? It's like a large, almost subfield, and string theory is like a quantum theory, right? Why is it a difficult question? Well, because we know what measurements are supposed to do, but it's just not clear how to draw the line as to when that thing happens and when it doesn't. What do you know about cold fusion reactions? What I know is that they can be induced via using they can be induced using muons, but there's never been any demonstrated case of using non-muonic hydrogen to do cold fusion. Seems like that this was just like a rabbit hole that some physicists went down in the 70s and 80s, if I remember correctly, and it was a dead end. Have you seen the whiskey that's made by chemically synthesizing the flavor compounds? I haven't, but I don't pay attention to whiskey a whole lot either. Working on a PhD can take a lot out of you. What do you do to help maintain your mental? Well, so I finished my PhD 4 years ago, so it's been a while. But I loved my PhD. I didn't have any mental health issues at all because like my PhD supervisor and I get along really well. The work that I was doing was really interesting. So like I loved it. From Eric S with the $2, why didn't the photon check any luggage? Because he was traveling light. Good joke. What was before the Big Bang? So cosmologists often talk about the hot Big Bang, which is the point where the universe was small, dense, and hot, and then it expanded. And before that, there is a fairly mainstream view that there was this kind of, I don't want to say event. There was this period of time called inflation, during which the universe was very cold, very empty, but it was expanding extremely rapidly, way faster than it's ever been expanding ever since. And it was basically doing that for all of eternity beforehand, depending on which version of inflation you take seriously. So in some sense, inflation was before the Big Bang. Is string theory outdated? No. No friction between magnets like you get with springs. You want friction on your shocks to do away with some of the energy, right? That's the whole point. Also, there absolutely is friction. When you move one magnet near another magnet, you're inducing a current, and that current produces heat in the magnet. These are eddy currents. Why, when you stop in a car, there's almost always an over-the-top jolt when you come to stop, no matter how slow you're going? I have no idea, and I've thought about this a lot. From Eric S. with the $5. A cop pulls over an electron and says, "Do you have any idea how fast you were going?" The electron replies, "No, but I know exactly where I am." It's a good joke. It's a good joke. If we could emit gravitational waves, could it be investigated as light was by Einstein in 1905? We can emit gravitational waves. They're just way too weak to be detected. Whenever you move something, you're emitting gravitational waves. All right, let's jump down to the bottom because we're a little bit behind. Is Christianity scientifically valid? I mean, kind of no by definition. It kind of requires miracles, right? From Ryan Gasling with the £5. Great stream. Ever come across Leonard Susskind's black holes theory of computational complexity? And if so, any thoughts? It went way over my head. I have. In fact, this was kind of related to some of my PhD work. I actually have a video on... maybe not on... I do have a video on using black holes as computers, but not on black holes, not on like how the volume is related to the complexity of the black hole and so on. But yeah, I mean, I am familiar with it. It's interesting. I'm not sure how convinced I am of all of this stuff that that relates information science to quantum mechanics. I'm a little bit skeptical of it, just because it seems like that it relies on a series of inferences which we don't necessarily have good justification for. Which solution to the black hole information paradox do you like the most? I mean, it just seems like that the black hole is going to evaporate and that evaporated, the Hawking radiation will carry the information out. Would you say that doing this stream topic is more or less profitable or more or less fulfilling than other topics? It really depends. Yesterday, we got a lot of donations, a lot of questions, so that was good. Is it more or less fulfilling? It's, in some sense, it's more fulfilling, but it's a lot more exhausting. Think about, like, so when I was a grad student, I lectured, you know, as like I was a lecturer for several courses, for like intro physics courses, and talking for 90 minutes straight is exhausting. Like, you can lose your voice very quickly. It's just something that's hard. And so when I do these live streams, I try to do them for at least 90 minutes. It is just talking. It's the same amount of talking as lecturing, whereas when I do debates, there's at least a back and forth. So it's I talk, then I talk again, and so it's less exhausting in that sense. But it is satisfying, especially when I get new and interesting questions. Easiest way to explain general relativity to a person? There isn't an easy way. I mean, you can use analogies like, well, okay, probably the easiest way is just to kind of shove the curvature stuff under the rug. Just say, look, there's this thing called space-time and it can curve, and mass is what makes it curve. And things want to travel in straight lines, but if the thing that it's traveling along is curved, then those straight lines will be curved. That's roughly general relativity. There's a lot more that's under the rug, of course, but it's good enough. Are you a Humean or non-Humean about the laws of nature? I lean Humean. If black holes colliding are additive, can it be assumed that they will never have a critical mass to destruct regardless of size? They already dissipate Hawking radiation, so they all eventually fizzle out. I don't know what you mean by destruct. I don't know what that means. From Midship Maniac with $5, some modern vehicles do use electromagnetic suspension. It's magnetic field applied to a ferrofluid. I don't know the specifics, but GMC does it. I mean, okay. Like, there might be some advantages to it, but I also imagine it's more expensive than just using shocks, especially if you're just talking about like a bicycle. Right. What is your view of the multiverse? Big Bang was not the beginning, just the beginning of our universe. I am skeptical of it, but I think that it's a totally fine idea. It's some, you might call it like the inflationary universe. I think that it's at least a sound idea that has legs. There are some problems, namely there's something called the measure problem, not the measurement problem, but the measure problem, which has some issues, but that's not really an issue with the physics. It's really with like kind of the foundational idea. It's an issue with like the way that we think about it. Angel cooked Blitz. I didn't even talk to him. Do you know Parker? And if so, do you like what he does? Yeah, Parker is like a either a close acquaintance or a loose friend. Parker and I used to collaborate a lot more often in the past before he was doing strictly political stuff. You know, he would do God debates, he would do flat Earth debates, and so I would come up on the occasionally. But yeah, like I've never actually had the chance to meet Parker in real life, if only because for most of that time I was living in Europe. But you know, if we ever run into each other, I'm sure it'd be fine. Are newer generations of physicists giving a side eye to string theory? Not really, no. Jump down to the bottom just so I don't get way behind. From Patrick, with the 2000 Hungarian forints, what's your opinion about the quote, if you can't explain it to a 6-year-old, then you don't understand it yourself? As a mathematician, I do feel there are ideas that can't be explained simply. I agree with you. I think that that quote is something that people who don't understand anything complicated say to feel better about not understanding when someone explains something to them. Now, it is true that, like, understanding something means that you should be able to explain it better. But, like, have a good time trying to explain, like, I don't know, the Yang-Mills mass gap to a 5 or to a 6-year-old, or, you know, trying to explain, like, what, I don't know, the Weyl curvature tensor is to a 6. Like, it's just not plausible. Are you a mathematician or a physicist? I straddle the line. What can you tell me about what SNOLAB is testing in Sudbury, Ontario? I don't even know what SNOLAB is, so nothing. Can you explain quantum chromodynamics? I will do my best, but again, based off of what I just said, it might be at too high of a level, but I'll do my best. So you have classical electromagnetism. Classical electromagnetism, you have positive and negative electric charges. Those positive and negative electric charges, if you have positive, it attracts negative, and negative attracts positive. Positive repels positive, negative repels negative. And the way that those forces are carried is via something called the electromagnetic field. So positive charges produce an electromagnetic field that negative charges want to move in the direction of. Negative charges produce an electromagnetic field that other negative charges want to move in the opposite direction of. So that's electromagnetism, and then you can basically ramp up all of the mathematics and turn it into a quantum theory, and you get quantum electrodynamics. Fine. Now, electrodynamics is like the simplest kind of quantum force field that we have. You could also imagine that you have a field that doesn't just have one type of charge, electric with plus and minus, but has 3 kinds of charges. It could have red and anti-red, green and anti-green, and blue and anti-blue. Now, these colors don't have anything to do with the actual color of the thing. They're just labels that help us with the mnemonic. Basically, red and anti-red can cancel out and give 0. Blue and anti-blue can cancel out and give 0, and green and anti-green can cancel out and give 0. But also, you can add red, green, and blue together, and you also get 0. Kind of in the same way that when you add those 3 colors together, you get white, and white is kind of like the empty color, or something like this. So, now you can talk about how things with red charge are attracted or repelled by things with anti-red charge. So they would be bound together. Red attracts anti-red, but also red, green, and blue all attract each other mutually. And these would be carried, these forces would be carried by a field that we call the gluon field. And then again, you can ramp it all up and you end up with quantum chromodynamics. It was very long-winded. Ken, thank you so much for the $20. Friendly, keep up the good work, man. I appreciate you. All right, let me drink some water and then I'll get back to answering questions. And from JC Ford with the $5, I appreciate that. Much appreciated. Okay. So like three phase and neutral being 120 degrees from each other, it's not quite that, because what you really do need a 3-dimensional space to model it. Or I guess it's a 2-dimensional. Yeah, you really do need a 3-dimensional space to model it, but it's similar. It's a similar idea. Does volume have a microscopic description? I mean, yeah, you could just say the volume of like a sound wave is just related to the local density of the particles in the sound wave. Or the magnitude of the pressure, which is related to the density and how fast the particles are moving, I guess. how fast the particles are moving in kind of an isotropic way. In your opinion, what's the most plausible eternal universe theory? I don't have an opinion on this. I'm pretty agnostic. There's a ton of them. I even have my own. Not to say that I think that my own is particularly good, but I think it's just an idea worth considering. So I am super, super agnostic on this. There's not one that I think I'm committed to, especially because the data doesn't really prefer one over the other. Why don't you debate Islamic Apex again? Stop running. I don't even know if I've debated him before, but if I have, he's always welcome to come on to my live stream. I don't know who that is though. Wait, is he he's not the kid, right? If he's the kid, then you know, you can't bring kids up onto live streams. Did you hear about the double charmed baryon they found yesterday? I did. Howdy, Mr. Earth Guy, I appreciate you. Has pursuing physics made you more or less religious? It hasn't changed it really at all. Just watch your What is Physics video. Do you write other poetry? I don't. No, I don't. Have you talked about the process of getting a doctoral degree? Yeah, so I mean, I have, but I'm happy to do it again. So at least in the United States, if you're going into a STEM field, typically what you will do is you'll graduate with your 4-year degree, with your bachelor's, and then you'll apply for PhD programs. And so you won't apply to get a master's first and then a PhD. You will apply straight into PhD programs, at least in STEM fields. And then if you get accepted, then you take a few years of classes. This is the equivalent of getting a master's degree. Sometimes you may write a master's thesis, but often not, especially if it's a straight to PhD program. And then you will do some sort of exam, or, you know, there will be some sort of test or oral exam or presentation that you have to make. And if you pass that, then you ascend to candidacy. And at that point, you're basically done with classes. You can still take them if you want, but you're basically done with classes. And then you find, hopefully during your during the master's part of your program, you found a PhD advisor who's willing to work with you. And for the next, 3 to 5 years, you work on a research problem, or you work on several research problems. Often, depending on the person, that can mean a lot of hand-holding from your PhD supervisor, at least at the beginning, or it can mean that you're kind of just thrown in and your PhD supervisor just kind of like watches from afar. It really depends on the supervisor and the student. The first while will be a lot of learning and kind of getting up to speed in that particular area of research, and then, maybe that's the first year or two. And then after that, then you have a problem to solve. Did you hear about the meteorite across Ohio? I did. What's your favorite naked eye celestial object? I really like Jupiter. Jupiter's really nice. It's just nice to look at, and you can see its moons. Do you think the brain working is a purely physical process? Yeah, I would think so. Are there actually jobs in astrophysics? I mean, yeah, there's just not a lot. But there's not a lot of jobs in anything, right? Has physics hit a dead end? No, absolutely not. Watches from afar and then writes their name on your paper. I mean, like, look, so this is like it's not like they're doing something wrong by doing that. There are different styles of learners. Sometimes people need more hands-on interaction, like almost like a collaboration with their supervisor. Other people need to be thrown into the deep end and left to work on their own. It just depends on the student, right? One's not better or worse than the other. But the point is regardless of who your supervisor is, they should definitely be involved somehow. Whether that means that they're letting you solve the problems, and then when you get stuck, you can go to them, and then they can give you like a tiny little hint, and then you go back, or whether they are, introducing you to colleagues that you can work with. Like, they should be involved somehow. From Tanner Yelovchich, I don't know how to say that. Thoughts on red light therapy? Also, do you have a favorite Pokemon? I don't know anything about red light therapy, but I'm very skeptical of things like that generally. But, maybe if there's science to it, then there's science to it. Also, do I have a favorite Pokemon? I haven't interacted with Pokemon in a long time, but I really like I played the starter Pokemon games on Game Boy because I'm old. I had Charmander, I had Pokemon Red, and I had Pokemon Yellow, but I really like Bulbasaur. What is Christoffel symbols and what do they do? Christoffel symbols are a way, Christoffel symbols basically tell you how much like an orthonormal vector. Okay, so Christoffel symbols don't need to be written in terms of orthonormal vectors, sorry, an orthonormal coordinate system, but usually they are. They tell you how much the coordinate systems deviate via parallel transport. So if you have some coordinate system, x, y, z, say, but the coordinate system is labeling your curved space, then the Christoffel symbols will tell you how the x coordinate kind of deviates away from parallel transport. Or I should say the integral curve produced by the x coordinate. Yeah. From Nectu with the $5, can you describe your feelings on the day you completed your PhD and finally received your certificate? Thanks. So I didn't get my certificate till like way out, like a few months after, just because the whole process is a thing. There actually might be a video about this, because I started on TikTok like a month before, like a very, very old video. I started on TikTok like a month before I got my PhD. So I may have made a video about it, but if I recall, like it didn't feel like a weight off my shoulders because I still had things I was working on, right? So, but it was neat that I could finally use the PhD label. That was nice. But yeah, it wasn't like, oh, I'm finally done. Like I didn't have that kind of release, if you will. Do irrational numbers bother you? They kind of bother me. No, I think it's pretty irrational to think that. No, I'm kidding. They don't bother me though. Have you heard of the oh my god particle? I have. Sometimes weird things happen. I made a video about it actually a while ago. From Telonius Gaming with the $2, there is an electric zebra Pokemon called the Blitzel. Well, that's fun. It's probably from like generation 9 though. What are the leading jobs for a physicist or someone with your level of education? Would they apply for jobs at a company or work for themselves? How does that work? Sorry. So if you're working as a physicist, most of the physicists, unless you're like an applied physicist, most of the physicists are working at national labs or universities. That's just the reality of it. Doing physics. There are a few private companies that will hire physicists to do certain work. Like you will find semiconductor physicists working at like semiconductor fabrication companies for like in like their R&D team. But that's probably in the minority of people who are actually physicists and not just engineers with physics degrees. So can we determine the size of the universe at the point of the Big Bang? So if you say at the point of the hot Big Bang, it just depends on which model you're using. Typically the kind of rule of thumb or the order of magnitude size that people estimate for the size of the observable universe at the point where physics stops working, it's about the size of a beach ball, like a large beach ball. That's how big the observable universe would have been. But the observable universe is not necessarily the whole universe, and you could in principle wind the clock back further, it's just we don't have the physics to describe it. Are you good at math too? Well, I'm a mathematical physicist, so I better be. From Ryan Gasling with the €5. Thank you so much, Ryan. Thoughts on the hype of AI producing new physics? Elon says it soon. I feel like when more compute becomes available, physicists exploit it anyway. There are probably physics problems that AI will be useful for, but I don't think that it's like the LLM kind of AI. AI and like machine learning and stuff like this has been used in physics for a while now to like better sort and better like find patterns in data that we haven't seen before. But the kind of physics that like the kind of theoretical physics that people do, it doesn't seem like AI is going to be particularly good at actually like doing that. At least not yet. Because it requires a degree of creativity that it probably doesn't have. Let's jump down to the bottom. What do you think of Penrose's book, Road to Reality, worth reading for non-physicists? I haven't read it, but I know it's really, really long. And I know it also, like, it's like half textbook, half pop science. So I don't know if I'd recommend it for non-physicists. But maybe I should read it at some point. It's just like 1,000 pages long, so... Difference between antimatter and dark matter. Antimatter is basically the same as regular matter, it's just kind of opposite. But we can see it just fine. Dark matter is a completely different thing. We can't see it at all. At least we can't see it directly. Is studying physics or math better for job opportunities? I don't know. I really don't know. I guess it depends on what you want to do. If you study physics, you'll probably learn some... You'll probably be able to get engineering jobs. If you study math, you'll probably be able to get like finance jobs more easily. But I don't know. Is more compute even possible? I thought we had problems with heat. Well, yeah, I mean, you can always just build more stuff, right? Could the antimatter star you spoke of produce enough Oort cloud annihilations with normal galactic matter to be easily seen? No, the point is that this would be sufficiently dim, sufficiently low mass, and have sufficiently weak, you know, kind of like solar wind, that the only, like most of its annihilations would just come from matter falling onto the surface of the star. Is nuclear energy a good career to get into? Yeah, probably. Do you take the view that space is fundamental? Also, why is space being continuous a problem in QFT? Space being continuous is not a problem in QFT. It's just not. It does introduce infinities, but that's just like, okay, whatever. We know how to handle those in QFT. I don't really, again, and I know this is dissatisfying, I'm pretty agnostic about whether or not space is fundamental. I think, like, I definitely lean towards there is like some underlying quantum like object that doesn't have space built into it, but again, we don't really have any data that supports that directly, that you have some, you know, failure for space to, or we don't really have any data that space is genuinely emergent, so it's really hard to make any definitive claims. Can Legolas's elf eyes see dark matter? They probably can. Also, can we just not, like, why can't we just say his eyes? Why do we gotta racialize it? Is antimatter real? Yeah, it's real and we can make it. It's just hard to make and it's kind of annoying to store. Are you still a professor or a full-time professor? No. So professor is an academic title, meaning that you have tenure, you work at a university. Like it's a title. Professor is a title. I've never been a professor. What I was is when I was in grad school, I was an instructor of record. What that means is that I was responsible for a course. I was, you know, I was the lecturer for the course. I made the tests and the exams, and I did all the administrative stuff. But that just makes me an instructor. It doesn't make me a professor. I've never had that academic title. Let's jump down to the bottom. Blitz, could we baryonic be embedded in a dark matter universe we can't see, and that's where all the other life is? I mean, I guess. I made a video a while ago on something called the dark sector. It's possible that there's just like 6 different sectors of matter, and you know, they're all mutually invisible to each other except via gravitation, and then they all would have their own life, and they could be like overlapping and stuff, but we don't really have any evidence that that's the case, at least not as it stands. And from Stratoblaster with the $10, I appreciate that. Yesterday was very entertaining. Today is way above my pay grade. I can't skip your channel, Blitz. Well, I appreciate you. Thank you so much, bud. Do you like teaching or in the field more? So in the field, for me, is like doing research. I like them both quite a lot. Teaching can get frustrating. And I imagine that I haven't had to worry about like teaching students directly at a university for a few years now, because my last postdoc didn't have any teaching responsibilities. But I imagine that it's gotten a lot worse now, just because the quality of students seems to have gone down. COVID seems to have hurt the quality of students. Universities have lowered their standards for acceptance, which means that that's hurt the quality of students. And AI has made it far, far easier to be lazy and to cheat. So I imagine that that's really frustrating. But generally, I do like teaching as long as the students are willing. From Vibing Tea, they say, would you advise finding a postdoc after a PhD, or is it better to go straight into teaching? It just depends on what you want to do. If you want a professorship at a university, like at a research university, then you need a postdoc. That's just the reality of the game. But if you just want to go, if you don't mind, like if you're okay just like going to teach at a community college or going to go teach at like a local university or something like this, you could plausibly go get a teaching position. It just wouldn't be a professorship in the research sense. What's the likelihood that the time-traveling electron theory is correct? I don't give it much credence because it kind of predates our modern understanding of quantum field theory. The reason why that idea was proposed was to explain why all of the electrons are the same. But now we have quantum fields, which better explains why all of the electrons are the same. I see you're just a regurgitator who never invented or discovered anything. I mean, tell that to my, like, more than a dozen academic publications that are all novel research. Have you built your own personal observatory? I believe the connection it gives is magical. I haven't. It's something that's definitely on my mind, though. I might when I, you know, my wife and I have plans to get a house sometime, maybe in the next year. And so, you know, there are some things that once I have more space available that I'd be interested in doing. Do you think quantum physics implies the existence of multiple universes? Not in the way that you're suggesting, not like, you know, not like Marvel, but I think it does probably imply the existence of many worlds, which are just kind of the same universe, just different branches of the same thing. Is loop quantum gravity compatible with Platonism? Platonism is probably compatible with basically every theory of physics. Because Platonism doesn't say anything about the non-existence of physical things, for example. Do you think it's possible worth it to learn physics from scratch? I just earned a software engineering degree. I mean, everybody learns physics from scratch. If you're asking learn it from like first principles on your own, I'm sure it's possible. I don't think I've ever seen someone who I've never met somebody who has successfully done it to the level where they are, you know, as competent as somebody with a bachelor's degree in it. That's not to say it's impossible. It's just, it's hard. It's way harder. Skip down to the bottom. What do you think about quantum gravity? I think that it seems plausible to me that gravity needs to be quantized and that gravity can be quantized. I'm not convinced of any one particular quantum theory of gravity as it stands. Like there's a bunch of people who have, or a bunch of people or teams that have offered, or like communities that have offered proposals for this is a good theory of quantum gravity. I'm not really convinced of any of them in particular, but it's also not something I spend a whole lot of time delving into because, again, I'm more of a classical GR guy. I dip my toes in quantum gravity stuff for other things that I'm interested in, but I don't really work on quantum gravity myself explicitly all that often. I have like one paper that's like explicitly quantum gravity, and even then it's pretty fringe stuff. How often did you use the quadratic equation? More often than you'd think. Could space-time and the quantum level just be a big superposition? Could be. What was your favorite physics PhD class? Well, so you don't really take classes during your PhD, but what you do is you take classes during your master's, during the master's part of your program. And probably the class that I liked the most was my advanced general relativity course. Can you still manage the master's degree if you forgot most of bachelor's? You should probably, you know, refresh your memory, but yeah, probably. Can you explain again why Penrose says that superposition is in conflict with relativity? So I'm not sure why he said it, but I can understand why someone would say that. Namely, relativity requires that you have a well-defined notion of where the mass, where the energy is. And if you have an object that's in a quantum superposition, it can be so it has to be a well-defined location for where the mass and energy is, and a well-defined amount of mass and energy, right? But if you have a system in quantum superposition, it could be, you could have like an electron that's in a superposition of multiple different locations. And then how does relativity interact with that? Or you could have a particle that's in a superposition of different energy levels. And then how does GR interact with that? Like how much does the space-time curve? Can elementary particles be created from nothing? It really depends on what you mean by nothing. Absolutely, elementary particles can be created from a vacuum, but vacuums aren't nothing. There are still quantum fields there. From sustaining Nimbus with the $5, I can imagine Dr. Blitz being a physics PhD examiner of a candidate who pioneered a novel use of Finsler geometry. Tell me, what shape is the Earth? Oh, that'd be so funny though. If they say flat, then they fail automatically. I don't care. I don't care what the justification is. What breaks quantum entanglement? Basically any interaction with just part of the system. Have we proven all of Einstein's theories yet? And which ones are proven recently? So Einstein is famous for like basically a few things. In 1905, Einstein produced 4 papers, all of which were groundbreaking. The first was, I don't remember the order. One of them was on Brownian motion, which was explaining how Brownian motion works. If you drop like a piece of pollen into water, the pollen will jiggle, or like apparently randomly. Einstein basically showed that this is because atoms exist. So that was, I mean, like we know that atoms exist, so that's we've known that atoms have existed for 100+ years. So that was confirmed. Another paper of his in that same year was the photoelectric effect, which is basically that photons exist. He explained that the photoelectric effect happens because photons exist, and we've known that they exist for 100+ years. So that's been confirmed. And then the 2 other papers in 1905 were basically laying out special relativity, which was confirmed in the 20s, probably, maybe the 1910s, 1920s. Perhaps even sooner even. And keep in mind, this was written in 1905. Then in 1915, he publishes his paper on general relativity. That's been confirmed over and over again. It makes a whole lot of different predictions. One of the predictions was only verified in 2015 when we detected gravitational waves for the first time, or maybe it was 2017, whatever it is. But the point is that there's a lot of features of general relativity that took it pretty advanced technology to actually verify. But the first observational evidence that verified general relativity was done in 1919 by Arthur Eddington. So it's been verified for a while. Then there's a few other like less well-known things, like he postulated gravitational waves explicitly in like the 30s, maybe the 20s. He talked a little bit about quantum mechanics, but that his view didn't end up being the predominant view. He talked about lasers, and then lasers were invented in the 50s. So basically all of his things have been verified. I can't think of a thing that hasn't been. Any like actual predictions. From Morgumi with the $2, I dropped out of physics PhD after a year. I'm sorry to hear that, but I hope it was the right decision for you. Does Physicist use homological algebra? Well, I don't, but I imagine that there probably are some who do. Couldn't you say the Earth is flat if the holographic universe is true? Still no. You said that a quantum system is more well-defined as a whole than it is for its parts. Can you explain? Yeah, so the thing is that if you have a quantum system that's composed of more than one particle, right, and those particles are entangled, then you can't capture the entirety of the system. You can't capture all of the features of the system just by looking at the parts individually because of the entanglement, right? The entanglement tells you that there's a correlation between the states of the particles that isn't captured by any one particle. And so you actually have to like analyze both particles together in order to see that, in order to actually pin down what that quantum state is. Have you read anything about CERN lately? No. You seen the new glob of Theia inside Earth? No. What makes a strong PhD candidate? Asking as a physics grad? Oh, I don't know. I don't even know if I was a strong PhD candidate. You should read a lot. You should read more than you think that you should read. Because it will be, as a PhD student, it's probably the last time you'll have to not really have a whole bunch of obligations. So you have more time to read. Also, attending seminars and showing genuine curiosity about other people's work is probably a good sign of a strong PhD candidate as well. From David Nikolai with the €5, do you think we could communicate through tachyons? I mean, if they existed, yeah, but they don't exist, so... Submitted your paper yet, my dude? Yeah, so a collaborator and I, we submitted a refereed paper, or we submitted a revision for a paper that we got the referee report back 2 weeks ago. We submitted that this morning. So hopefully we'll hear back from the referee. We basically did everything that the referee asked, with a few exceptions. And so there should be no issues getting it accepted. Have you seen that new study that discovered a charm down particle? I have. I don't know why people are so excited about this, though. Is mass linear in time and EM wave closed in time? I don't know what that question means. What was your PhD in? It was in physics. Just says Doctor of Philosophy in Physics on my diploma. Tachyons don't exist. Tachyons don't exist. At least not as like particles traveling faster than light. There are things called tachyonic instabilities. The Higgs boson has, or the Higgs field has such a thing, but this is not something that has anything to do with faster than light travel. Can you explain strong and weak nuclear force like I'm some kind of idiot? I guess. So we can talk about the nuclear forces, not their underlying quantum phenomena. So the strong force is easier to explain. You can just think of it as literally like glue holding nucleons like protons and neutrons together. The way to kind of think about this is sort of the way that kind of the way that like atoms bond in a covalent bond. It's sort of like that. It's not quite the same, but it's sort of like that. The only the biggest feature of the strong nuclear force is that it's very, very strong when the two nucleons are very close together, but its strength drops off very quickly with distance. So if they separate even a little bit, there's basically no more force. The weak nuclear force is a little bit harder to explain because at the nucleon level, it's not really a force. Essentially, all that it is it's a mechanism by which protons and neutrons can turn into each other. Does black hole generate gravitational waves? Yeah, they do when they orbit things. Were you always good at physics? Hard to say because I didn't really take a real physics class as a high school student. So, but in undergrad, yeah, I was good at what I was doing. We need a huge video explaining it if you get it published. I mean, it's not my first publication, and it's not even a really important paper. It's just like a kind of a, yeah, like we didn't even submit it to like a top tier journal because it's not a super important paper. It was just worthwhile getting this particular idea out there so that it could be seen by other people in the field. Can a physicist have normal work-life balance and or family? I mean, yeah, but you're going to be working a lot at the beginning of your career. What is a Calabi-Yau manifold? So this is a Kähler manifold. What's the full definition? I'll explain what these terms mean in a minute. I just gotta make sure that I don't leave anything out. Okay, so this is a, oh no, it's yeah, so okay. So it's a even dimensional manifold that has Ricci flatness. Definition, this is what I want. The definition that I like, the one that I'm typically fond of, is the one that, yeah, the structure group of the tangent bundle of M can be reduced to U of N, the unitary group, from U of N to the unitary group to SUN, the special unitary group, in a manner that is compatible with the complex structure. Or M has a Kähler metric with global holonomy contained in SUN. So, look, it is tricky to explain this to somebody who isn't familiar with a lot of these terms, but I did make a several minute long video about this a while ago. One of the features is it has to behave like an empty universe, right? It has to be so-called an Einstein manifold. And then any curvature that it does have, the curvature that's left over, has to have a very specific property, namely the holonomy of the manifold has to be a very specific, or the holonomy of the metric has to take a very specific form. But explaining what all those terms mean without going into the details is a little bit tricky. So I will recommend you go watch my video, which does go into the detail and tries to keep it understandable. Do atoms know they're atoms? I don't think atoms know anything. Could you define mass in terms of capacitance? Have you heard about this? No, I haven't heard about that. I don't know how you would. What is a tachyonic instability and what does that have to do with the Higgs field? So one of the what gives a field mass, and when we're talking about particle physics, we're really talking about like quantum fields. What gives a field mass is the shape of its potential energy, namely that it looks like a quadratic thing. If there's a quadratic term in its potential energy formula, so you know you can have a potential energy for a field. if there's a quadratic term so that it looks like a parabola, that means that it has mass. It has a positive mass. A tachyonic instability, and so like then the field in some sense can kind of like oscillate back and forth at the bottom of the potential well. And the amount of mass is related to the steepness of the potential well, basically. A tachyonic instability is when you have a field sitting at the top of a quadratic potential that's pointed down. And so it's unstable, so it will roll down the hill. This is what the Higgs field did during spontaneous symmetry breaking. Hence why it's called an instability. And the reason why it's called tachyonic is because the mass squared, in the case of the mass squared is positive when you have an upright parabola, but it's negative when it's inverted. And so if you have your mass squared being negative, then that means that you have an imaginary mass, which is what we mean when we, which is what a tachyon would have to have in order to be moving faster than the speed of light. It would have to have an imaginary mass. So that's why it's called tachyonic. Are you an atheist? I am. Where do quarks come from? They come from the quark fields, which I know is not a satisfying answer, but it is the right answer. There are, as far as we can tell, there are fundamental fields that permeate all of space-time. Some of those fields are quark fields, some of those fields are lepton fields, some of those fields are, you might call them force fields, like the electromagnetic field, for example. And what we call particles are simply excitations of that field, localized excitations of that field. And that's what quarks would be. Do you prefer more geometry view or algebra view of physics? I prefer a more geometric view, but that's because I'm a GR guy. Can the event horizon infall rate of a black hole ever equal the space-time ejection rate of a white hole? So there's not an infall rate. You can talk about like the like surface gravity of a black hole at the event horizon, which is not really meaningful, but it's sort of meaningful, but I'm not really sure what you mean by like the infall rate. And also white holes don't exist. Could quantum entanglement solve Heisenberg uncertainty principle, one measurement from each? No. So there's nothing to solve in the Heisenberg uncertainty principle. The Heisenberg uncertainty principle is just a fact of nature. It's not it's not an issue with our measuring ability. It's just a fact of nature because everything is made of waves. That's it. Like that's the whole thing. And waves have intrinsic uncertainty, namely that if you want to localize your wave to a single location, then you can't have a whole bunch of little wavelets because then it would be spread out. On the other hand, if you want to know the frequency of the wave to a high degree of accuracy, you have to have a whole bunch of wavelets to measure the frequency, or in this case the wavelength, precisely, so that you can take a whole bunch of data and average them. And so the point is if you want to know the position well, then you can't know the wavelength well, and if you want to know the wavelength well, you can't know the position well. That's a fundamental feature of how waves work, and because everything is waves, then you just get the Heisenberg uncertainty principle. Would you know anything about radiation, perhaps? I have a question I've always wanted to ask. I mean, yeah, I know stuff about radiation. What's the difference between algebraic and geometric physicists take? I mean, like, I wouldn't say that there's algebraic physicists and geometric physicists, but like, quantum field theory is very much an algebraic, it's very much like an algebraic, like the mathematics is very algebraic. And I say algebraic in like the abstract algebra sense, not like in the doing algebra, like, you know, x squared minus 4x plus 2 equals 0 kind of thing. Generally you'll find the people who like geometry more, they tend to lean towards gravity more. And so it's just like a preference thing, because the way that we understand gravity is through geometry, and the way that we understand quantum field theory is through like operator algebras. So, you know, it is what it is. Is physics academia very much competitive like computer science? Yes. Why isn't there a formula like the quadratic or PQ formula for functions like f of x equals x to the 5th plus x to the 3rd plus 7? So you're talking about why isn't there a solution? Why isn't there a general formula for the quintic in terms of radicals? This is due to, I guess solving this problem was able. But the general theory of Galois, of Galois groups, Galois theory, explains this. And essentially it's because, what's the statement? The alternating group of 5 elements, or what is the symmetric group on 5 elements is, I don't know, there's something about one of the groups being non-abelian or something like. It's been like 10 years since I've done Galois theory, but there's a reason, and there's a reason why it happens at 5, and it's because of group theory. From Swearwolves with the $10, a bit of a weird one, but any recommendations on layman basic resources for learning how things move that could be useful for animation? Like movement, forces, torque, gravity, that sort of thing. Well, look, so I don't know. The closest thing I could say, like, you could just pick up a mechanics textbook. You know, you might need a little bit of calculus, but I guess you could get like an algebra-based physics textbook that just goes over Newtonian mechanics, and that would do what you want it to do. There's also a book by Sean Carroll called The Biggest Ideas in the Universe. And I think it's like the first, like part 1 or something, that goes over kind of mechanics and this stuff, so that might be helpful, but that's a little bit more pop science-y. Yeah, hold on. I need to go look up the I need to go look up, because otherwise it's going to bother me. This is the thing about the quintics. The Abel-Ruffini theorem. So it was proved by Abel, and then I guess technically it was done by Paolo Ruffini first, but it was incomplete. And there's a group theory explanation, which is that... right. So, okay, so it boils down to the fact that the symmetric group S5 is not solvable, where solvable means something very specific. In fact, for any n greater than or equal to 5, the symmetric group is not solvable. And so that is the final step that Galois, I think this was due to Galois, that Galois showed that you can get this general result here. Anyway, I should go back to answering questions rather than being nerd sniped. I took a class on this, but it was 10 years ago. From Shane Strife with the $2. Hi, Blitz. Have a great day, everyone. Yeah, everyone, have a great day. And we got a Cash App from someone. Oh, lots of Cash Apps. I should pull these up, just so then I don't miss them. From Rob with the $1 for, it's not much, but I hope it adds up. Well, you're appreciated, Rob. From Josh, no need to read, my bad. From Juno with the $10 for, what does my aura say? Will I fall in love? Your aura says that, what's that thing? Your aura says nothing. Will you fall in love? I hope so. And from Grana with the $5 for, I like the Star Trek references, Quark and Galron. Not Galron. I'm quite fond of the relationship that Quark and Odo have in DS9. It's just they have such good on-screen chemistry. Can you explain emergent complexity? Yeah, I mean, it kind of by definition, complexity is emergent. The idea is that you can have very, very simple rules. By the way, the simplest example of this is something called Conway's game of life. You can have very, very simple rules that describe how a system changes over time. And those very, very simple rules, if you put enough of those systems near each other, the way that they interact with each other, you can develop extremely complicated structures that you probably wouldn't have predicted in advance, because predicting them would have required extreme computational power. So what you should do if you want to look into this more is look up Conway's Game of Life, and in particular look up spaceships in Conway's Game of Life. From Bacon and Bush with the 10 Dr. Blitz Debunks gift memberships. Thank you so much. If you guys don't know, becoming a gift member or becoming a member on either of the YouTube channels, either on the horizontal or vertical YouTube channels, is only like $5 a month, and it supports the channel. And you also get access to my debate notes and emojis, so consider it. It's a great way to support me if you want to, and you don't want to spend a whole lot of money on it. From L'Oreal Ashley with the $10. Just send in a heart. I appreciate you, L'Oreal. All right, let's answer some more questions. What do you think about Roger Penrose's CCC theory? He's not wrong often. Yeah, so the only reason why people even consider it is because he's Roger Penrose and because he's brilliant. The thing is, you might be wrong on this one. Like, Einstein got stuff wrong occasionally too. Do neutrinos have mass? At least 2 of them do. Yeah. I'm getting a phone call, I'm sorry. Sorry about that. Just, you know, I told them to call back in half an hour. It wasn't a business call. It was a call from it was a medical call. Let's put it that way. Neutrinos barely have mass. Yeah, they barely have mass, but they do, at least 2 of them have mass. Yeah. It was actually a call from the State Department. You're right. You're right. What's the deal with that dark matter galaxy that was found recently? It's just a galaxy that has a lot more dark matter than most galaxies do, and not a whole lot of regular matter. Which is just kind of weird, right? From Draconic Drizzt with the £5, ignore the Earth currency, sent you enough gold pressed latinum for a Rectigino. Much appreciated. You know, it's funny that they have their own version of coffee, the Klingons, right? Can't help but like Penrose, even if CCC isn't quite the view I prefer. I actually really like CCC. The trouble is I think it's probably wrong. If it was right, my PhD research becomes a lot more relevant to physics. It's just probably not right. That's the reality of it. What's exciting you in the world of physics right now? It's not some particular experiment, but the fact that we have increasing observational evidence that maybe dark energy is not a cosmological constant, that is very interesting to me, and it's prompted me to consider a whole bunch of, you know, perhaps not so plausible, but maybe like toy models of the way the universe could evolve in the future. From David Nikolai with the €5, some interpretations of data from the dark energy spectroscopy and spectroscopic instruments suggest that neutrinos may have negative mass. What do you think? I think that if that's the conclusion you come to, I think that we are probably I think that there's probably good reason to dismiss that those interpretations, because if you have negative mass, then like everything goes out the window. I mean, like, maybe that's what we need to do, but that seems like that should be the last resort, right? Is choosing safer non-competitive option when applying to PhD admission good choice? No. No, not if you want to go into academia. So the way academia works, as you progress in your career, you start as an undergrad, then you go to grad school, then you do postdocs, and then you hopefully get a professorship, and then maybe another professorship if you have to move somewhere else. The way that these work is that they filter down from highly competitive, highly reputable, high prestige. They filter down. So if you went to a really prestigious undergrad, you will have an easier time getting into a prestigious grad program, and an even easier time getting into a less prestigious grad program. But if you went to a not very prestigious undergrad, you will have a harder time going up in rank, going up in prestige. So the advice I would offer to anybody who is trying to go the academic track is stay as prestigious and as high rank and competitive as you can for as long as you can, because it will make later moves in your career easier. Which is, it's unfortunate that that's how that works, but that is the reality. Why do people talk about before the Big Bang if time started from the Big Bang? Well, that's not really the consensus view. The consensus view is not that the Big Bang was the beginning of time. I hope I can win a membership one day. Well, hopefully you will. But if you have $5 to spare a month, then you could also just get it yourself. How does the Big Bang produce around planets? Well, it's not really direct. It doesn't go Big Bang straight around planets. It goes Big Bang, small inhomogeneities that lead to gravitational collapse of very early, very massive stars. Those massive stars then explode. They produce higher, like higher mass atoms, or atoms with higher atomic number. And then this happens for a few cycles, and eventually you end up with new stars that form in the gas of the explosions of the old stars. And then some of those stars, some of that gas is hydrogen, and that filters into the middle, and you get the star burning. And then some of the other mass is like not hydrogen, maybe it's like iron, or maybe it's nickel or whatever, and so that forms orbits. So that starts to orbit around the protostar that's forming in the middle, and then the protostar, and then those planets, those rings, they eventually coalesce into planets via gravity, and you end up with planets. I think I made the mistake in choosing a much worse university. Look, that is the reality of that is the reality of it. I chose so I went to a big state school for undergrad, not like low ranking, but not particularly high, but I did well enough in undergrad that I could like move up in my prestige. So I could go to a higher ranked school for grad school, but I had the opportunity to go to UCLA for grad school, but I turned it down because, I don't know, I just didn't like the fit there. I just didn't like the culture there, which, in hindsight, was that a mistake? Maybe, for my career. Maybe if I had gone to UCLA, I would have had more opportunities present themselves rather than having to fight the whole way. But I liked the person that I ended up doing research with. I liked the research that I ended up doing. So I'm not, I don't think I would change things. You should prove gravity exists before you claim it does something. Oh, that's been done for like the last 250 years. Why not UC Irvine? I don't think I applied to UC Irvine. But UCLA is just a better school than UC Irvine, right? Right, like it just is more prestigious. Would entropy break down when entering a black hole? We don't really understand how entropy and look, there's like a consensus that the entropy of a black hole is proportional to its surface area, but we don't really have a good microscopic description of why the entropy of a black hole is proportional to its surface area. So that's not a question that we have the ability to answer yet. What do you think about the difference between QFT's value of vacuum energy and the observed one? I think that the fact that they're different means that they're unrelated. Gravity does not exist. That's crazy. Go try jumping off a building then if you don't think gravity exists. How difficult was the math required for your degree? Well, I did a double major, one in mathematics and one in physics. So the math got tricky near the end, but I still did well. How would it look if you were racing speed of light at c minus 1 miles per hour? Light would still look like it's moving at the speed of light from your perspective. Dr. Blitz, can you explain how quantum fields interact with each other? Can they be quantum entangled with each other? They can be quantum entangled with each other. Yeah, they can. How they interact with each other? There is just an interaction term between them. They talk to each other via the gauge boson fields. So like the electron field can talk to, I don't know, some quark field or something like this. Or maybe, the electron field can talk to the muon field by communicating via the electromagnetic field. And like, that's just, like, if you want something deeper than that, we don't have a deeper explanation. That's just what electrons and muons and electromagnetic fields do. If you're moving at the speed of light, would you be able to see it all? Well, you can't move at the speed of light. I know this is a physics chat, but I'm curious if you've read anything by Isaac Asimov. I have not. Could stable states of matter form at generation 2 and 3 fermion energies in our universe? I don't understand the question. Generation 2. So we can talk about like the different generations of. Oh, I see what you're asking. No, probably not anyway, because it seems like they would just decay, like almost instantly. Sorry, I just gotta check something. Can you please explain Newton's third law? I get that Newton's third law is force equals gravitation. No, that's not Newton's third law. Newton's third law is that if object A applies a force to object B, then object B applies a force of equal magnitude in opposite direction to object A. It's often said that every action has an equal and opposite reaction. That's Newton's third law. What you're talking about is Newton's universal law of gravitation, which is just that the force is equal to the gravitational constant times the products of their masses divided by the distance squared. But you don't understand how or why it works. Well, look, it's an empirical law. This is an observation that Newton made. That, you know, if this formula did work, then or if this formula was true, then all of the observations on the planet and all the observations of the planets in the sky would also make sense. So this is just like an empirical observation. There's not really like, I mean, you could go read the Principia for an explanation as to why, but if you want to figure out how it works, you just plug in the numbers and that gives you a force. Can we theoretically move at the speed of light? If so, how long would it take us to achieve this? No. No, we cannot, because we have mass. How precise is the gravitational law? Like how many digits? It depends on which one you're talking about. Newton's universal law of gravitation, I think we have pinned down to like 6 or 7 digits or something like this. Theoretically, does something have to be massless to move at the speed of light? Yes. What's the difference between special and general relativity? General relativity has gravity. How much of Newton's laws of motion still hold true in QFT or quantum mechanics? They don't really. At best, you can like reformulate them so that there's something that's kind of similar, like momentum conservation is still a thing, and Newton's three laws of motion, are basically just momentum conservation. But the way that they're phrased is just not really relevant in quantum field theory. Do you think that QFT's renormalization is only a trick or it tells something about our world? I don't have a strong opinion about it. See, on the one hand, the way that that renormalization is typically taught is just that, look, the things that we measure are the already dressed quantities, like when we measure the mass of an electron or the charge of an electron. These are the quantities. That are already have interacted with the quantum systems or with the other quantum fields or themselves. And so you can't just plug that in as your initial data into your quantum theory, because the initial data has to then be modified, has to be dressed by the stuff that happens to it to get a measurement out. So on the one hand, this is just telling us, look, like, you were just doing quantum field theory wrong. And so you have to just do it right. And then once you do it right, you get reasonable answers. On the other hand, this idea of renormalization, or perhaps better is regularization, tells us something about like emergence, right? And this idea goes back to Wilson, Kenneth Wilson in the 70s, I want to say, this idea that you can talk about effective field theories in a really efficient way, using this idea of renormalization if you just forget about the stuff that like at you know, ultra high energies or very, very zoomed in or etc. So I think that I'm kind of on the fence about it. This idea of emergence tied with renormalization that Wilson's approach has, I think is a very deep one. But I also think that this idea that we're just measuring the dressed quantities rather than the undressed quantities just tells us that it's not really a trick, it's just something that we had to learn to do right about quantum field theory. Can you explain why the Entscheidungs problem proves that no universal logic I have no idea what that is. Do you think string theory is potentially just mathematical beauty rather than empirically viable? I mean, it might be empirically viable. The problem is it's very hard to see which of the empirical models of string theory is the one that represents our universe, if any of them. Dr. Blitz, do you believe time travel is possible via time dilation when moving near the speed of light? Forward travel, not backwards. Yeah, absolutely. That's absolutely a thing. Definitely. You currently work in the private sector or academia? I work for myself. So I fund my own research. because I can make more money doing science communication and social media outreach and stuff than I would at a university. So I can afford to be flexible, and I don't need an academic job in order to get to do the research that I want to do. Have science got the smallest part of atoms, or is it likely there's more things to discover? It's impossible to know, right? If space-time is emergent, what is it emerging from, and how could we experimentally verify that? We don't know, because we don't know if it is emergent. If I could tell you that, then I would just go and do it, right? Do Gen 2 and Gen 3 fermion states support multiverse theory? I don't see how they're related at all. Do you think there's a solution to the grandfather paradox if wormholes are real? I think that the grandfather, okay, kind of yes. There's this idea of something called, or there's this notion called Novikov's consistency. What is it? It's Novikov's self-consistency principle, and I made a video about this a while ago. But essentially, if backwards time travel is real via wormholes, then you have to have something like the Novikov self-consistency principle. Otherwise, you just lose the ability to do physics, and we can do physics. So that means that either backwards time travel is impossible, or you have some self-consistency. Was string theory a rabbit hole without constructive use? No. It was absolutely very constructive, and it's not done either. Do you think quantum computers will reach their potential in the next years? Maybe. He engages questions he can dominate. He exits questions that would require conceding ground. What? What does it mean to exit a question? The monetization breaks create cover for the exits. The pop culture references reset the rooms. Oh, this guy's a Nazi. Oh, okay. I see. From James Pesh with the $2. How much would you charge to read an amateur book? I don't know what you mean by an amateur book. If you mean like a science book written by an amateur, I probably would just turn you down. I generally don't have time to like read papers or, you know, books by people who aren't, who look, so when amateurs write these things, papers, books, whatever, they're usually a waste of time just because they're amateurs, right? They're usually a waste of time. And so I just don't have the time, enough time that I can commit to figure out that something is a waste of time, because then I would have wasted my time doing that, right? I don't know if that was sensible, but hopefully you understand what I mean. From Nick with the $5, how would you explain atoms to someone who thinks atoms are not real? I mean, you could tell them about Brownian motion and how Einstein basically showed that Brownian motion implies the existence of atoms and molecules. But at this point, we have images of atoms that are like real atoms. We have scanning tunneling electron microscopes that can see the individual atoms with like a machine, right? So would you read it for 10K? Yeah, I guess I would. For 10K? Sure. But maybe they want you to read for their audiobook. Oh, if that's what you mean. I don't know, maybe. Bro just offered to pay you. So look, there is this idea, and I did this when I first started out on TikTok, when I first started doing science communication. I had this idea that like, because crackpots, and I say this with love, crackpots, amateurs, people who had like theories of everything or whatever would message me a lot. And so I basically said, look, I will charge you $100 an hour. And we can do, like, I will do consultations and I will look over whatever you have to say, or whatever you want to show me. But when I was doing that, I did it once, and it felt like I was just taking advantage of somebody who like had some kind of mania. And I don't want to like diagnose anybody, but it felt like I was just taking somebody's money to tell them that they're wrong and to make them feel bad. And I didn't really like that. So I stopped doing it after the first time that I was offered. So that's why I tend to not do this kind of stuff where I like it, you know, if you pay me, everybody has their price, right? If you pay me like $10,000 to read something that'll take me like 2 weeks, I mean, I'm going to take it, right? But, you know, it's just not something that, I don't know, I just don't want to be doing that on the regular. Will I record a Flurf audiobook for $10,000? Yeah, I would just read it. I would just read it in a sarcastic voice the entire time. God, I'm hungry. Oh, you know why I'm hungry? Because I woke up at like 3:30 and then I ate breakfast at like 5. Can we not make an atom with 120 atomic number in the lab? It's just hard to make heavy atoms, that's all. People are working on it. I'm sure that it'll happen in the next 20 years or something, but what are quarks? Can we observe them? Quarks are the particles that make up nucleons. So protons and neutrons are made up of quarks. We can't observe them directly, but we can observe their effects. In particular, what you can look up is you can look up jets. They're called hadron jets. And these are produced when quarks are knocked out of baryon, or knocked out of nucleons, like protons. Basically, if you knock a quark out, because of the physics that describes them, they can't really be observed alone. But because they're knocked so far away, they basically produce in it like a shower of jets that come out. And so there's a deep explanation as to how we, or there's a whole explanation, like a whole long story about how we figured out that quarks are actually things that exist, even though we can't directly detect them. But the phrase to look up if you want to look more into this is something called deep inelastic scattering. Will you read my Dr. Blitz and allegedly in fanfic for $10,000? I guess, yeah. Or maybe I'll just take the money and lie to you. I don't know. Yeah, Renewts, look, the point is I understand that people think that their ideas are good, and I hate being the person to tell you that your ideas are not good. It just feels bad to do. Even if you give me money, like, it feels bad to do. Like, imagine, okay, it's definitely not this bad, but imagine being like a doctor, and your only job was to tell people that they were gonna die. That was your whole job. Like, it's not that extreme, obviously, but giving people bad news for money it's miserable. Could you explain what entropy is? Yeah, entropy, in some sense, entropy is subjective. But at least in certain thermodynamic situations, we can try to define it in a canonical way. And in that sense, entropy is a measure of how many ways the system could have been microscopically without changing how the system looks macroscopically. So the more ways that it could have been microscopically without changing how it looks macroscopically, the higher the entropy. From Sky 1 Dabs with the 2 Canuck bucks, quarks have so much cool physics around them. They do. It just gets really, really messy really, really fast, right? Ever heard of John Breaks Bad News? No, I haven't, and it sounds miserable. Why is everyone super interested in black holes? They aren't even that big. I mean, they are pretty big, but also they're just so cool. I don't know what more you want. Even theoretically, is entropy reversible? Yeah, absolutely. As long as you have a contained system that is where each state is independent, there's a word for this, not hysteresis. As long as you have a contained system that is allowed to explore phase space uniformly, it will eventually reach low entropy states from high entropy states. Why are there no crackpots when it comes to fluid mechanics? Because the only crackpot problem that fluid mechanics would invoke would be solving the Navier-Stokes equation, and that involves understanding partial differential equations. From Skydabs with the 2 Canuck bucks, what do you think of white holes? I think that they're not real. We don't have any like proposed mechanism for how they would form, and we don't have any evidence that they exist observationally. Like, they'd be really bright. So we don't have any really reason to think that they exist. How many hours do you work a day? Depends on what you consider work, but usually, especially if I get into a groove, I can be working till like 6 p.m. before my wife drags me away for dinner. And I usually like start, it depends on like how early I get up, but like I usually start at like 7 or 8. So I work a lot, and I work on the weekends too. it turns out when you work for yourself, it's hard to have work-life balance. Do you wear glasses to seem smarter? No, I wear glasses because I'm blind without them. Could dark energy be caused by another potential field? Absolutely. Yeah, this is one of the main ideas. There are things like quintessence fields, phantom fields, you know, just various scalar fields, axion fields, a whole bunch of things. Why do we think dark energy is pulling instead of pushing? We don't really describe it either way. That language is not particularly useful when we talk about general relativity. From Mindforged Manacle with the $2 shame, the glasses do make you look smarter. Well, I appreciate that, but that's just not why I wear them. Wouldn't a white hole be indistinguishable from a bright quasar? Not necessarily. I mean, like, yeah, I guess you could work out the spectrum, but. All right, I do have to go because I'm expecting a phone call back in like 5 minutes. So I'm going to end the live stream here. Thank you guys all for being here. Thank you guys all for listening and asking good questions. If you do want to ask more questions, the place to go is to join the Discord server. If you're 18 years or older, go to discord.gg/drblitz. It's a great place to be. You can ask questions. I will answer questions there, and other like-minded people will also answer questions there. In the meantime, I will see you guys tomorrow for some more debates. Take care, everybody.